Welcome back. So today we're going to be working on 11.3, which is applications involving the quadratic equation. So these are all going to be word problem type questions. So the first one that we have here is we are going to be finding the value of t when v equals 8 and when v equals 15. The voltage in an electric circuit is given by the equation v equals 8t squared minus 28t plus 20, where t is milliseconds. Okay, so t is time, and that is counted in milliseconds. So we're going to be using our quadratic equation two different times. So one time when v is 8 and one time when v is 15. Okay, so we're going to start with v equaling 8. So essentially we're going to come up here to this equation and we're going to plug 8 in where we have the v. So we're going to have 8 equals 8t squared minus 28t plus 20. And then from here, we're going to be using our quadratic equation. So we need to have this equal to 0. So we're going to subtract 8 from both sides. So we get 0 equals 8t squared minus 28t plus 12. So then from here, we're going to figure out if there are any common factors, which we can, if we look at this one, we have 8, 28, and 12, so I see 4. So I'm going to divide both sides by 4, because remember, as long as we do the same thing to both sides, then our equation is staying equal. So like I said, I'm going to take a 4, so that's going to leave me with 2t squared minus 7t plus 3 equals 0 over 4 is still going to give me 0. Okay, so we have this simplified just a little bit, makes it a little easier to work with. So now from here, I'm going to be creating our two binomials. So remember when we did this before, the AC method that we had, we're going to take 2 times 3, which is 6. And factoring that, 1 and 6, since this is positive and this one is negative, the signs are both going to be negative, and we're going to do the sum. Okay, because we're going to have two negatives that we're adding together to give us this middle term. So that's going to be our 1 and 6 would actually give us the 7. So we're going to go 2t and t. So then this is going to be 1 and this will be 3. So then that gives me my outers would give me the 6. My inners are going to give me the 1. So negative 6, negative 1 gives me that negative 7. All right, so then from here, we're going to separate these out into our two different equations. So 0 equals 2t minus 1, and 0 equals t minus 3. And I'm actually going to erase this and scoot it over just a little bit. Just so I have room here for this one. Okay, so I'm going to scoot up just a little bit here. All right, so now I'm going to be solving these two to find our roots. So we're going to be adding 1 to both sides. So 1 equals 2t, so dividing by 2. So 1/2 equals t. On this one, we're going to add 3 to both sides. So we get 3 equals t. So then for v equals 8, we end up getting our two answers to be t equals 1/2 millisecond and 3 milliseconds. I'm actually going to put an and there instead of an or. Okay, so those are our two roots for v equaling 8. All right, so now we're going to do v equals 15. So same process, just now we're going to, instead of plugging in 8 for v, we're going to plug in 15. So we're going to go 15 equals 8t squared minus 28t plus 20. Again, we have to move the 15 so that we have this equal to 0. So minus 15 from both sides. So 0 equals 8t squared minus 28t plus 5 this time. So now with this one, we're going to be using the quadratic equation instead of just factoring. So for this one, I'm going to say my a equals 8, b equals a negative 28, and c equals 5. So then I can plug this in. T equals negative b plus or minus the square root b squared minus 4ac all over 2a. So then let's plug in our numbers. T equals a negative b, so a negative 28 plus or minus the square root. B was a negative 28 squared minus 4 times A is 8, and C is 5, divided by 2 times A, and A was 8. So now we're just going to be simplifying. T equals negative times a negative is a positive, so this is a positive 28. And then we have our plus minus square root negative 28 squared. So if we punch that into our calculator, we're going to get a positive, and that's going to be 784. And then we have 4 times 8 times 5, so minus 160 divided by 2 times 8, which is 16. So we're going to continue to simplify underneath this radical. T equals 28 plus or minus 784 minus 160 gives us 624. And then we're still dividing by 16. Next one, we're going to take the square root of 624. So 28 plus or minus. Remember, we're going to 3 significant digits when this isn't exact. So that's going to give us 25.0. And then that's divided by 16. So then T equals 28 plus 25 over 16, or T equals 28 minus 25 over 16. And then we get, this is going to give us T equals 3 significant digits again. I'm getting 3.31. Oh my gosh, I apologize. Let me scoot up here. So again, here I was just splitting out this one into 2 separate equations. So one is plus, one is minus. And then I punched that into the calculator. 3 significant digits. I'm getting 3.31 milliseconds. And then for the other side, I'm getting 0.188 milliseconds. Okay, so those are my different options for these 2 equations. So it said, find the value of t when v is 8 and v is 15. So we found it for 8. Here's our answers for 8, and here's our answers for 15. Okay, I do have a couple more of examples for you guys. So let's go ahead and go on to the next example. Like I said, these are all word problems. So this next problem says we are going to design a rectangular plate so that its length is 6 centimeters more than twice its width, and its area is 360 centimeters squared. So I'm going to go ahead and put area equals 360 centimeters squared in here. It says its length is 6 centimeters more than means we're going to add, then twice its width. So let's say its width is x, then that means that its length is going to be 6 more than twice the width, so 6 plus 2x. Okay, let's see. So first we have our picture here. We've labeled the different pieces. So then we're going to use the formula. Sorry, I'm just looking on here to see exactly what it's wanting us to find. So we're going to find the length and the width. So in order to do that, we need to use the equation A equals length times width. Okay, and we know our area is 360. We know the length is 6 plus 2x. And we know the width is x. So then if we actually multiply this out and distribute, we get 360 equals. I'm going to move this x in the front since that's going to be the higher degree. So this is going to be 2x squared plus 6x. So now you can kind of see why we're going to be using the quadratic formula or factoring here. So for this one, again, we want it to be in the format of the ax squared plus bx plus c equals 0. So we're going to move 360 over to the right-hand side. So we're going to subtract 360 from both sides. So we get 0 equals 2x squared plus 6x minus 360. So now from here, the next thing that I notice, the next thing you should always be looking for is, do those different terms have a common factor? Each one of these terms has a common factor of 2. So I'm going to divide by 2 on both sides. So we end up with 0 still on the left, because 0 divided by 2 is still 0. On the right-hand side, though, I'm left with x squared plus 3x minus 180. So I just divided each one of those terms by 2, and I get this new trinomial. So now it's a little simpler, a little easier to work with. So then my next step, we're going to be breaking that apart. So we've got x and x. We have a negative here and a positive here. So that means we're going to have two different signs. One's going to be positive, one's going to be negative. So then we need to figure out our factors of 180. And we want the difference to be 3. So 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 36, 6 and 30, see 8, no, 9 and 20, 10 and 18. We're getting closer. We need a difference of 3. Let's see, 12 and 15. Oh, I found a difference of 3 here. So we're going to use 12 and 15. We need the larger one to be the positive. So we're going to put the 15 here and the 12 on the negative side. Okay, so now that we have that factored into binomials, we can split those out into our two separate equations. Say 0 equals x plus 15, 0 equals x minus 12. So on the left, we're going to end up with x equals a negative 15. On the right, we get x equals a positive 12. Okay, so then if we think about this, can the width of our rectangle be a negative number? So this is where, yes, those are both roots, but do both of them work for the scenario that we're talking about? Well, we can't have a width of a negative, so that means our width has to be 12. If our width is 12, then what is our length? So our width equals 12 centimeters. So the length equals 6 plus 2 times 12. 2 times 12 would be 24, plus 6 gives us 30 centimeters for our length. So then that's what we would get for our answers on that one. Okay, all right. So let's go on to another application problem. All right, so this next one we have here, we have the perimeter of a rectangle is 20 centimeters. Its area is 16 centimeters squared. We are going to find its dimensions. So we want to find length and width. All right, so for perimeter, what do we know about perimeter? So we know perimeter is going to be 2 times the length plus 2 times the width. Okay, we also know that that equals 20. Let's see here. Other things that we know. I'm just going to draw a picture. So if we know, let's say the length, actually, let's say our width is x, then our length would be 10 minus x. Now the reason why is this side plus this side should equal 10. Because if our perimeter is 20, half of the perimeter would be 10. So one length plus one width would equal 10. So that's why I took 10 minus whatever this is. Okay? All right, so then I'm going to plug that in up here. When we're dealing with area. Okay? So area, we said, was length times width. And in this case, we've decided that 10 minus x is our length and that x is our width. And we know that our area equals, what did they tell us? 16 centimeters squared. So we're going to say 16 equals the length, which is 10 minus x, times the width, which is x. Okay, so now we have our equation set up so that we can solve for x. Again, we're going to distribute this x. I've got 16 equals 10x minus x squared. We want this to be set up in that form ax squared plus bx plus c. So I'm going to move the 16, subtract it from both sides. So we get 0 equals. I'm going to put my x squared in front since that's the highest degree, so that's a negative. negative x squared plus 10x minus 16. Okay, so then from here, we're going to be factoring, because I don't see anything, well, I can take a negative out of this. So I'm going to divide by a negative 1. So I'm going to make everything essentially switch the signs up here. So we have 0 equals x squared minus 10x plus 16. Just because it makes it a little easier when this is a positive x squared as opposed to a negative. So then we can break it up into those binomials, x and x. So dealing with the 16, 1 and 16, 2 and 8. Let's see, we have a positive sign here, a negative here. That means they're both going to be negative. Negative times a negative is a positive. So we want the sum to be 10, which is this one right here. So we're going to go 2 and 8, and these equal 0. So then I can write my two separate equations. We've got 0 equals x minus 2, 0 equals x minus 8. So then we have x equals 2 and x equals 8. Okay, so then from there, that tells me that the width, both of these are positive, so both of those could be potential answers. Width is 2 or 8. Okay, if our width is 2, that means our length would be 8. If our width is 8, our length would be 2. Okay, so just something to keep in mind there. You'll notice the dimensions are essentially the same. It just depends on which one you're associating length with and which one you're associating the width with. So you can write that out any way you want. The length and width of the rectangle are 2 centimeters and 8 centimeters. Okay, and like I said, it can be length can be 2, width can be 8, or width can be 2 and length can be 8. It doesn't make any difference. All right. Okay, so that was example 3. I do have one more example. I know this video is getting kind of long, guys, so I do apologize for that, but I do have one more example I'd like to go through. This one looks a little bit different. For example 4, we have a square is cut out of each corner of a rectangular sheet of metal that's 42 centimeters by 52 centimeters. So I drew that out already. So I've got the whole width here and the whole length of 42 and 52. The sides are then folded up to form a rectangular container with no top. Okay, so we're cutting out these little square pieces. So they're telling us these are squares. So that's why I called each of these x. So then what's left here is 52 minus 2x, because we have 1 on each end. And what's left here is 42 minus 2x, because we have 1 on each end. Okay? It says, what are the dimensions of the square, the shaded part that we're cutting out, if the area of the bottom of the container is 1,200 centimeters squared? Okay, so just this bottom piece is the 1,200. So this length times this width gives us this area. Okay, so we are going to find the volume of the container as well. So first thing we're going to do is figure out what x is. So we're going to take area equals length times width again. So just like we did in the last one, but this one goes a little bit farther. So we're going to go 1,200 equals 52 minus 2x times 42 minus 2x. Okay, so we're going to go ahead and multiply this out. So using the FOIL method, we get 1200 equals first times first. I get 2184. So first times first. Then we're going to go outer times outer, inner times inner, and we're going to add those together. So I get minus 188x. Oh, I apologize. Got ahead of myself. This should be x squared, right? Oh, no. It's not. It's just in the wrong order. Minus 188x. Now we'll get the x squared. So a negative times a negative gives us a positive 4x squared. Sorry, that threw me off with the x squared being at the end. All right, so again, we do need it to be equal to 0, so we're going to subtract the 1200. And I'm going to move my x squared in the front so that it's sitting in standard form in that decreasing order. So I want 4x squared minus 188x plus, let's see, I get 984 is what I'm getting there. Okay. So then the next step, remember, we're going to look and see if there are any common factors. So common factors that I'm seeing for this one, 4. I'm going to take a 4 out of all of it. So then when I divide by 4 on both sides, I end up with x squared minus 47x plus 246 equals 0. So again, that just makes it a little easier to work with. So then we're going to break this apart. X and x. This one's positive, this one's negative. So that tells me they're both going to be negative. And then I'm going to have my 246 that I've got to come up with factors for. So I've got 1 and 246. 246 would be 123. The 246. 3 would be 82. 4 does not go in there evenly. 5 is not going to go in there evenly. So let's try 6. 6 goes in there 41 times. That one looks like that's going to get pretty close here, and we do want to sum. This one's going to work. It's going to give us 47. So we're going to go 6 and 41. So then solving both of those to find our roots, x minus 6, 0 equals x minus 41. We end up with x equals a positive 6 and x equals a positive 41. Again, both of those are positive numbers. So we have to look a little more carefully here and see if one of those is actually going to work with this scenario or not. So let's see here. So if I plug 41 in here, actually let's do 6 first. So 42 minus 2 times 6. So 42 minus 12 would give us 30 for that inside dimension. If I did 41, 42 minus 2 times 41, that would give us 42 minus 82, which would be a negative 40. So this x equals 41, that's not a plausible solution. doesn't work. Okay, because we can't have a negative 40 for an inside dimension. That wouldn't make any sense. So that means x is going to be 6. So now that we know that x is 6, we can plug in and find, so this one was our width. We can plug in and find our length as well. So 52 minus 2 times the 6. 52 minus 12 gives us 40 for our length. Okay, and if we take 40 times 30, that is going to give us our 1200 for our inside dimension there. So we have found the dimensions. So we also have found the x. Let's see here. What was the question? What are the dimensions of the square? So the square is 6 centimeters by 6 centimeters. Okay, so that was the first part. The next question was to find the volume of the container. So volume, I'm going to scoot down here just a little bit. Remember, volume equals length times width times height. Okay, and so if we're thinking about the height of that little box, when you fold the sides up, the height is going to be x. So volume equals length, which is 40, times width, which is 30, times height, which we said was 6. So when we punch that into our calculator, 40 times 30 times 6, I'm getting 7,200. So the volume of the container is 7,200 centimeters cubed. Remember, this is volume, so our units are cubed. Okay. All right, so that is the last example for you today. So you do have practice problems. I don't have all of your practice problems written out here because, again, these are word problems. But I did write them down here. So you have 11.3 practice is on page 256 and 257 of your packet. It's 1 through 13, every other odd. So there's actually only 4 of them that you're doing. I'll zoom out just a little bit here. So you're doing 1, 5, 9, and 13. Those are the only ones that you have to do on the practice problems. So take a look at your packet and go ahead and complete those 4. And if you have any questions, please let me know, and I'll see you in class tomorrow. Have a great day. Bye.